and at some point it reaches a critical value when the water is released to the eastern side and the El Nino happens. And when water is released, that's the discharge state. So the Western Pacific and basically tropical Pacific is cooler. Like here, the red line is the warm water volume, and the Nino 3 index is the black line. So before the El Nino happens, the warm water volume decreases, and then when it reaches the minimum value, La Nina happens after that. And La Nina will build up the warm water volume by bringing warm water from the eastern Pacific to the western Pacific. And then when it reaches a critical value, again the release happens, the El Nino happens to go to the La Nina states. So that's how the El Nino, La Nina states can be explained by this kind of warm water volume recharge and discharge. There are other theories like ocean dynamics. If you use oceanic waves, if you have strong winds, that kind of winds, as you can see that we have easterly winds in the northern Pacific and easterly wind in the northern Pacific, off equatorial winds. And that kind of wind can cause Ekman convergence in the Western Pacific. And that converged water, which is warmer, can be radiated towards the Indonesian coast, Philippine coast, as Rossby waves. And that Rossby wave will eventually find a boundary through the Philippines and Indonesian coasts and will reflect it back to the equator to travel as Kelvin waves. So Kelvin waves need a boundary, so equator is a solid boundary for it. So that's why Kelvin wave will travel from west to east as warm Kelvin wave, and then the El Nino will happen. Opposite thing happens when El Nino happens and the winds are weak. So we have divergence, low water volume, so cooler water volume. Now cold water propagate to Philippines and Indonesian coast as Rossby waves, and then they reflect to the equator, and then cold Kelvin wave starts, and that cold Kelvin wave will eventually go to the eastern Pacific and will cause the La Nina. So this is a good theory. Ocean dynamics can explain the transition from the El Nino to La Nina and La Nina to El Nino, depending on the Earth's interactions, what's happening because of the wind convergence and divergence. However, that kind of Rossby waves and Kelvin wave will take just 1 year to cross the whole basin. So that's why we must experience El Nino, La Nina every 1 year. But that's not happening. It's mainly because of other factors like the monsoon, the interseasonal oscillations, and other factors which are disturbing this kind of ideal Earth interactions. So that's why we don't have a periodic 1 year El Nino, La Nina cycle, but a periodic El Nino, La Nina cycle, which is kind of 3 to 7 years. Sometimes we experience El Nino in 3 years, sometimes in 7 years. So that's why, and the other factors, noises, affecting this kind of ideological Earth interaction to cause. But you can see sometimes this kind of ideological situation can be seen in the real world. The Rossby waves propagating. You can see the cold Kelvin waves are starting now here. They reflect and now the cold Kelvin wave started and the La Nina phase started. So from El Nino to La Nina transition. So this theory can explain the transition from El Nino to La Nina to El Nino, but cannot explain the periodicity of El Nino and La Nina. Similar situation happens in the Indian Ocean. So we have the positive dipole and the negative dipole, very similar to the Pacific El Nino and La Nina. It's just in a reverse sense, because usually in the Indian Ocean, wind blow from west to east, from African coast to Sumatra coast. So that's why Sumatra coast is higher in temperature, normal, this is a normal situation, and the Somali coast is cooler than Sumatra coast. So that gradient is maintaining the wind, and the wind Walker circulation is maintaining the SST gradient. In that sense, they are coupled, but in some years, either this Walker circulation weakens or we have strong wind in the Sumatra region, which takes away warm water from the Sumatra region to Somali region. So Sumatra region gets cooler and Somali region gets warmer because we have upwelling in the Sumatra region and water is driven away, so that's why Sumatra region is cooler and Somali region is warmer. So once Sumatra region is cooler, we have less convection, less rainfall, drier situations, so droughts. However, because of upwelling, we experience good fish catch because upwelling can bring nutrients to the surface, and that's why we have more fish catch during positive Indian Ocean dipole years. On the African side, they experience warmer temperature, less fish catch, and floods because of heavy rain. This is the schematic of Indian Ocean dipole influence in many parts of the world. So the blue and hatch means cooler and drier situation. So whenever positive Indian Ocean dipole happens, we have a cool, dry condition over Indonesia and maritime continent, and also some parts of Australia. So that's why we experience drought, but good fish catch. However, the Somali region, African region, East African region, some parts of Europe, Japan, East Asia, they experience more higher temperature, like warmer temperature, and Somali region gets more rainfall because of convergence. So that's how the Indian Ocean dipole can also be teleconnected to other part of the world through the atmospheric teleconnections. And that's what is the teleconnection, that's how the teleconnection happens. One is the direct influence because of convergence and divergence in the eastern side and western side of the Indian Ocean. The other one is like propagation of Rossby waves. These are atmospheric waves propagating at 200 hectopascal, 300 hectopascal. But once they propagate, they affect the atmospheric condition all over the world, especially like the South American coast, we can experience warmer temperature because of positive Indian Ocean dipole. And similarly for the Europe, we also experience warmer temperature because of the Indian Ocean dipole through that teleconnections. Now some people believe ENSO and IOD are very well connected and kind of same phenomena, but it's not true. There are some years when the IOD, positive IOD co-occurs with El Nino, but not always. So they are independent, but there are co-occurrences. When they co-occur, their influence will be very strong, but when one of them is happening, that will have an unique influence, like 2019 IOD. There was no El Nino in the Pacific, but 2019 IOD has a strong influence on Indonesian side as well as the African side. They're state dependent and phase dependent. Sometimes they're coupled, sometimes they're not coupled. And the implications are for the predictability and how they're affecting the extremes. What are the future projections? There are many scenarios. Some models say that we'll have more El Nino phenomena, increased frequency of El Ninos and extremes, but there are uncertainties in their feedbacks. I'll kind of list up some of the papers here. Kai et al. Said in 2014 that we'll have more frequent extreme El Ninos, and then the warming will be faster in the eastern equatorial Pacific. But there are also some studies which says that we'll have increased frequency of extreme La Ninas. So if you have more La Ninas, it's good news for some regions. First of all, the global temperature will not rise as much as it's expected because of cooling effect coming from La Nina. And it is also good for the fishery of the Eastern Pacific, but it's not good for agriculture in Peru and some of the South American countries, also west coast of US. There are some studies which says that, okay, the variability of ENSO kind of dependent on the greenhouse gas related global warming, but some studies says it may not be true. As you can see here in this study, we see that if you take from 1980 to 2022, it's more like La Nina state. So if it's a La Nina state, it's still better than El Nino state. If it is El Nino state, the temperature will be much higher. Global temperature will be much higher. Now the next question is, what will be the impact, future projections of ENSO impacts? There are some studies say that if you have more El Nino-like state, then Indonesia will experience droughts, more drier conditions, because it's El Nino state, so the Indonesian side will have cooler state, the western side of the Indonesia will be cooler state, so that's why we may experience drier state. But please remember that when we have more El Ninos, we also expect more positive Indian Ocean dipoles. Actually, the mean state of the Indian Ocean is favoring more positive Indian Ocean dipole. So also the eastern side of Indonesia, it will be cooler. So both sides are cooler. It will be kind of double punch. So this is the scenario which is not good in the future. However, if you have more La Ninas, then the western side of Indonesia might get more rainfall, whereas the eastern side, because of more positive Indian Ocean dipole, might get drier. So we'll have a diverse kind of climatic effect coming out of La Nina state and positive Indian Ocean dipole state. There is also another scenarios. Some studies, some models suggest that we'll have more El Nino Modoki-like state. El Nino Modoki is slightly different from El Nino, when the central Pacific is warm and eastern Pacific and western Pacific are dry. So that means if you have more El Nino Modokis in the future, the eastern side of the Pacific will remain slightly drier, but the western side also will remain slightly drier. So that means Indonesian region also will be drier. However, the islands, Pacific islands, will get more rainfall, which is also bad news for them because flooding and sea level rise. Future projections of IOD. So the mean state of the Indian Ocean, as I said, is favoring more positive IODs. So we expect more extreme positive IODs will happen in future. This is defined by SST gradient, what we are experiencing already now. And that's also not good news for Australian climate, because Australia also will experience more drier state than what we have now. So shift in the dominant patterns, increased Central Pacific influence. If we have El Nino Modoki in the future and positive Indian Ocean dipole in the future, their combination will be different from positive Indian Ocean dipole and El Nino. El Nino Modoki actually favors more positive Indian Ocean dipole. So that's another way to say that if you have more positive Indian Ocean dipole, we can also expect more El Nino Modokis. And the co-occurrences of ENSO IOD will decrease because you'll have more El Nino Modokis compared to El Ninos. I already said we are experiencing more positive IOD-like phase and consecutive events are quite common. Consecutive positive IOD events are quite common. So the influence also will be stronger in future climate. So this is a kind of summary of all projected changes. In the future, ENSO frequency expected to be higher. But at this moment, we don't know whether it will be more La Nina-like or more El Nino-like. So if it is more La Nina-like, we'll have a different state. If it is more El Nino-like, it will be a different state. So in next 10 to 20 years, I think we'll see more evidence whether we are going towards more La Nina-like state or more El Nino-like state. The intensity, change in the intensity in the future, many models suggest that we'll have more intense El Ninos, more intense La Ninas. And the consensus among models is quite high in that sense. The Indian Ocean dipole projected change in frequency, we didn't see much change, but some models are predicting more positive Indian Ocean dipole and consecutive positive Indian Ocean dipoles. So the consensus is not so high, it's in medium level. However, the models are predicting extreme positive phases will be higher. Then the co-occurrence of ENSO and IOD is different models are predicting different things, so it's variable. We cannot say if the co-occurrences will be higher or lower. So that's why the confidence of models, consensus on models are low to medium.